Welcome back, students, to one more session of your inorganic chemistry. That is, I said it is a combo series of your grade 11 and 12. Right. So in the previous video, I've given you the introduction of what are the combo classes, how it's going to happen in that. So in today's video, let us see the first question. The topic which I chose is ionic bond. So basically, I'll start with the basic information. I'll gradually take you into the 11th, then I'll gradually take you to the 12th class. Right. Stay tuned and keep writing or keep noting along with me. So the first question of our series, that is the combo classes, which I'm going to start today, is explain the factors that influence the formation of ionic bond. Right. So basically, we all know, right, what is an ionic bond? We have two types or three types basically: ionic bond, covalent bond, and coordinate covalent bond. So in the first type of bond, which I'm going to discuss, basically ionic bond is formed. How is it formed? It is formed to transfer of electrons. Okay, transfer of electrons. This is what we have studied in grade 10, isn't it? Transfer of electrons. Covalent bond is sharing of electrons, correct? Right. So in ionic bond, when there is transfer of electrons, now the question asked is explain the factors that influence. So basically, this transfer of electron, where does it happen? It happens from one atom to another. From one atom to another, isn't it? This is a basic concept. Now, when this process is happening, for example, let me take an example and tell you. Suppose if we have magnesium chloride. Magnesium chloride is an ionic compound. How will we know? We have studied this in grade 9th also. That is your crisscross method of writing the formula. What do we write? Basically, in magnesium, atomic number is 12, isn't it? So, let me write it in the form of 9th class format. That is K, L, N, M, and N shell. So, 2, 8, 2. So what is the valence electron present? 2 valence electrons are present. Let me take the next example. Chlorine, atomic number is 17. So again, let me divide 2, 8, 7. So how much should it get? It should get one chlorine has to get 1 valence electron so that it attains stable octet configuration, isn't it? Right. So let us take, what does it do? This magnesium has 2 valence electrons. What it does, it's going to give one chlorine, 1 valence electron, and one more chlorine, 1 more valence electron. Yes, during this transfer, what happens? Magnesium, let us write, it's going to transfer these 2 electrons to 1 chlorine here, 1 chlorine. This is transferred to 1 chlorine. This is going to transfer to 1 more chlorine, and then it forms an ionic compound, magnesium chloride. This is the basic thing which we have studied in grade 9th, isn't it? Yes. Now, what is important? They've asked, explain the factors that influence the formation of ionic bond. So, for an ionic bond to form, 2 important things you have to remember. First, the important concept is the element whichever, so the atom whichever is donating to this. Now this is donating, this is accepting, isn't it? Right. So the atom whichever is donating, or the first atom whichever is donating. Let me write this as first atom. What is the first atom which is donating? First atom is magnesium. Always this magnesium should have lower ionization energy. Remember, or smaller ionization energy. If the ionization energy is small, means I can easily, let me write, smaller ionization energy. Right. What is this ionization energy? The ionization energy is the energy required to remove an electron from the outermost shell. Yes, so always remember, whichever is donating should have smaller ionization energy. Let me come back to the second atom. The second atom, what is the second atom this is doing? It is accepting. Here it is chlorine. Here, whichever is the second atom, this is the first atom. Easily, if there's smaller ionization energy, I can pull out the electron of this. I can pull out this electron and give it to this. Right. So smaller ionization energy. The next second atom should always have the higher electron affinity. Higher electron affinity. Remember this. These two are the important factors. Higher electron affinity means the ability to attract the shade pair of electrons. Means the ability to attract that electron. Done. The first atom should always have lower ionization energy so that I can pull out the electron. The second atom should have higher electron affinity so that it will drag the electron. So these two are the factors on which the ionic bond is formed. Done. I think this is easy, students. Right. Let me come back to the next question. Very interesting question to you all. Let's see this. So what is the next question? What are the general, now we have known what are the factors for formation of ionic bond. Let's see what are the general characteristics for ionic bond. So whenever an ionic bond has to form, as we know, it is transfer of electrons. What are the factors? Let's see, write one after the other. So basically the general characteristics on what ionic bond depends is, first factor is melting and boiling point. First let us write the factors, then come and discuss each one of them. First is melting and boiling point. The second factor on which the ionic bond formation depends is hardness, right? And the next factor and again, what should I say, the hardness or this particular concept of the characteristic, it's again going to depend upon two factors. What is that? It depends on hardness, depends on ionic radii, and it also depends on charge. Let me first write all the factors and then come back to you. Charge on the ions, right? Next, third one is brittleness. Third one is brittleness. Okay, right. Now what is the next factor on which it depends on? It basically depends upon one more factor, that is a fourth factor, that is cleavage. Okay, cleavage is a factor on which it's going to depend. We'll discuss one after the other slowly so that the concept is clear to you all. That cleavage is one more. When I have to see one more factor on which it depends on is solubility. Let us write solubility and later discuss it. After solubility, one more factor which ionic bond depends on is conductance. And one more factor, very important factor on which the ionic bond depends on is stereochemistry. Okay, let me write that here. I'm dividing the page and let me make the seventh factor as stereochemistry, right? Stereochemistry. So let us discuss one after the other clearly. Now when I have to come to the first factor, what do we say? The first factor is nothing but melting and boiling point. So for ionic bond or for an ionic bond to form between two atoms, these are all the factors on which it depends on, correct? Let us discuss melting and boiling point. Now what actually is melting and boiling point? So basically what involves melting point, what happens in melting point? So during melting point during melting, what will happen? We all know it involves breaking of crystal lattice. The atom and the crystal in melting, basically it's going to, or the crystal lattice is going to first break. After breaking of crystal lattice, what will happen? The electrostatic force of attraction means we very well know in ionic compound there is positive cation and negative anion. So what is the force of attraction between them? Electrostatic force of attraction. Now the crystal lattice is broken down and immediately the electrostatic force of attraction between the positive charge and negative charge. So what is this force? This is called electrostatic force of attraction. I'm writing it in shortcut, attraction. So what will happen to this? Between electrostatic force, they generally strong. Between ions are generally strong. So what do I require? I require lot or have to use strong force to break down, because the force of attraction is between positive and negative. So I require higher energy to break down this. What will happen? That's why to break this bond, I require higher energy. Hence, what will happen to the melting point and boiling point? They should obviously have high melting point and high boiling point. High melting point and high boiling point. You understood, students? So here, what is the concept? First of all, there is electrostatic force of attraction between positive cation and negative anion. To break this force, or to break this electrostatic force of attraction, I require high energy. So that high energy is nothing but high melting point and high boiling point, right? So here there are variations also in melting and boiling point within ionic compounds. What are they and what does this depend? Basically, this melting and boiling point, it depends on two factors. What are they? One, the first factor is charge on the ions. The next factor which depends on is ionic radii. Okay, ionic radii, same like hardness also. So what happens is, for example, if I take sodium chloride crystal, let me see. Sodium chloride crystal, what is this in sodium chloride crystal? It is 2.81 angstroms. Okay, internuclear distance. And if I take barium oxide, the internuclear distance is 2.7 angstroms. Here for sodium chloride, let us write that. Okay, let me take one. Okay, let me draw one line for you all so that's clear. What did we discuss? We said in sodium chloride, basically here the internuclear distance is how much? It is 2.81 angstroms. We measure it into angstroms, isn't it? Now I have taken one more example, that is barium oxide. Barium oxide is almost 2.7 angstroms. So what will happen now? This is the force or the distance between both the atoms. Now in this case, when I take sodium chloride, the melting point of this is 800 degrees centigrade. Now here the melting point is 1921 degrees centigrade. How much? Here the melting point is 800 degrees centigrade, and in this case the melting point is 1921 degrees centigrade. See the difference. So the higher melting point, why barium oxide has a higher melting point? Because there is strong interaction between barium cation and anion. So the electrostatic force of attraction between them is very strong. Hence, I require so much of temperature to melt it. Yes, fine. Compared to sodium chloride. So once again, because of the stronger force of attraction between barium and oxygen, the we require means high temperatures compared to sodium and chloride, right? So this force of attraction, because of this, as I told you, the difference means because of the charge. I told you the charge as well as ionic radii, these two factors. See here, the charge is Na plus, here the charge is Ba plus 2. So charge is higher, ionic radii also is higher. Because of these two factors, we have high melting and boiling point. Let us come back and discuss the next one. Let me draw a line again. Yes. So what is a hardness concept? So basically, again, when we speak about hardness, what is the factor which is acting between ionic compounds? It is nothing but electrostatic force of attraction. So when do we call electrostatic force of attraction? When there is attraction between positive cation and negative anion. Yes. Now here in ionic compounds, the electrostatic force of attraction, if the electrostatic force of attraction is stronger, hardness also will be more. Correct? Right. So here what happens, I said there are two factors on which the electrostatic force of attraction depends, or the hardness depends. I'm sorry. Hardness depends. What are they? The first factor I said, it is ionic radii. Then I said charges in the ions. So what happens, as I said, suppose if the what do you say, ionic charge, the given ionic charge, hardness increases with decrease in distance between the crystals. Correct? Yes. Once again, when I have to say in the other way, hardness always increases with increase in charge. Correct? Yes. Once again, let us come back. For this case, for a given ionic charge, hardness increases with decrease in interionic distances. Right? Let us write that. For the first case, what will happen? Hardness decreases with which one? With hardness decreases with increase, or for the given ionic charge. So this particular thing decreases with increase in interionic, with increase in interionic distance, isn't it? Yes. That means, what am I trying to say? If the distance between both the atom increases, I can easily break. If can easily break means hardness decreases. Both are inversely related. If they are strongly held together, it will become very hard, isn't it? So as the distance increases, hardness decreases. Right. Let us speak in terms of charges now. What do we say? I said, let me write the charge concept. Right. Hardness increases with increase in charge. Increase in charge on ions. Okay, right. How can we explain this? I think the first one you've understood, students. Second one, hardness increases with increase in charge of the ions, we said. How is this possible? Let us take an example. Suppose if I take lithium chloride, okay, then if I take strontium oxide, what will happen? Or if I take one more, that is sodium chloride structure, the interionic distance is 2.57 angstroms only. So we said that hardness increases as we move from, means as the charge increases, as we move from lithium chloride to strontium. Basically, how is this like? Lithium from lithium. I said what examples I took. I have taken lithium chloride. Yes. Then I have taken strontium oxide. So when I move from lithium, the charge is Li plus, and I am going to move to strontium. Strontium charge is Sr plus 2. Right. So what will happen? As I said, as I move, as a charge increases, the hardness of the crystal also will become, because they're tightly packed, isn't it? So the hardness also increases. Done, students? Once again, as the distance increases, ionic radii increases, the intra-ionic distance increases, hardness will become less. I can easily break it. As a charge on the ion increases, hardness also increases, because the crystal lattice, the cations are fixed, or the cations are tightly fixed in the crystal lattice, and it is packed together, and hence hardness increases. Right, this is clear, students? Right, so these two concepts we need to remember. Let us come back to the next one. Brittleness, we say. So brittleness is, what is brittleness? Basically easy to break, very brittle in nature. I can easily break it. So what will happen is, okay, let me draw one diagram and show you. Here in the crystal lattice, how does it look? We all know the cation is smaller in size and the anion is larger in size. The cation is smaller in size and the anion is larger in size. Smaller in size, like that. So opposite. Now for the cation we have anion. For the anion we have a cation. For the cation we have an anion. Like that, oppositely charged will be present always. Correct? Right. So it observes that when energy is supplied to this crystal layers, when I supply energy to this, what will happen? The movement of the layers of the ions means it will bring, when you start supplying like this, in this way, I'm going to supply energy in this direction. Okay, yes, it will like this. Then what will happen? The movement of these layers of ions, it makes the ions of like charges near. Because when you are supplying, the ions of like charges will start coming, because it will just move like this, isn't it? It will just move like this. How does it look? Then cation, anion. Now here for the cation we have anion, and there is a movement of this energy like this. So similar charge, anion comes closer. Just see here. And then again for this cation, and one more, if I have to see, it will slide up like this. And this, one more anion like this, it comes off, and below this. Now what is the difference between this? Because energy, when you're trying to supply energy, here they were oppositely charged, but in this case similar charges have come closer together. Now what will happen? Because of the similar charges, it starts repelling. Strong repulsions will be there in that. When repulsions are there, here attractions were there, and here what are there? Repulsions are there. So when repulsions are there, what will happen to that crystal? It will start breaking down. It will break down. Correct? When it starts breaking down, what will happen? It's nothing but brittleness, isn't it? For this reason, ionic crystals, though they are hard, because of this concept of brittleness, they are brittle and can be powdered easily. So this is sodium chloride, salt, if I take, comfortably we can grind it and make it into powder also. Correct? Crystallized salt. Right? So this is one concept of ionic bond, students. So because of this energy supply, I can easily break the bond and make it into powder. So the first concept was melting and boiling point. The next concept is hardness. Third concept is brittleness. And let us see the next concept. That is nothing but cleavage. Okay. So when I have to speak about cleavage, what is this cleavage? Here, this is basically a grade 12 topic where we'll be studying about isotropy and anisotropy also. Right. Let's see. So here, this phenomenon of cleavage, it's observed in ionic crystals. What is this? So it's nothing but it's splitting of layers. Means, or in crystals, what will happen? That splitting of these layers, one layer of the other, is easy in some direction or other. Let me show that. For example, if I take, now let us, what is cleavage? It's nothing but splitting. Suppose if I take an example of sodium chloride. Okay, now I'm taking an example. Here, let us assume the crystal of sodium chloride. I have one after the other arranged in this direction. Between these, I'm again arranging, and one more layer. We have two-dimensional, three-dimensional arrangement, which you will be learning in grade 12. I'll be teaching that also gradually. In this way, cation, anion arranged. Now, here when I take, this is which point? This is the cleavage point. Okay, this is the cleavage point which you are doing. Here, what happens in sodium chloride crystal? I can achieve this cleavage only along planes parallel to Q faces. I can attain this cleavage only to the plane which is parallel to Q faces. Only parallelly I can break. Suppose if I am trying to break the crystal in this direction, like this. Suppose if I am trying to break the crystal like this. Here, cleavage is possible, but in this case, when I am trying to break the crystal or cleave the crystal in such a way that means it is not, which is not parallel, it will immediately shatter the whole crystal. The whole crystal shatters, means it breaks off. Right? So here the cleavage is possible. Here the cleavage is not possible. Understood, students? It will shatter if you go like this. The concept of means the complete crystal lattice will get shattered. Done. Let me see solubility concept. Let me draw a line so that it is not confusing to you all. So when I speak about solubility, basically ionic crystals or ionic bond, they have both positive cation and anion. So in the solubility concept, ionic compounds are highly soluble in polar solvents. So what are polar solvents? Water is a very good solvent. Correct? So what should you write? Ionic compounds. Ionic compounds are highly soluble in polar solvents. So like polar solvents, like dissolves like. Correct? So water is a good solvent. Why water is dissolving all the ionic crystals? Two important concepts. What are they? First, it has very large dipole moment. Okay, there is a concept of dipole moment which I did in my videos. Please watch that. Okay. Next, because of this large dipole moment, high hydration energy is also observed. That concept also, hydration energy, I have taught. The next concept is water has high dielectric constants. How much? It is 78.5. 25 degrees, it is 78.5. So because of this, it is responsible for reducing forces between cations and anions in solutions. Because of the high dielectric constant, it will reduce the attraction between cation and anion, and this keeps the unlike charges apart and they start dissolving it. Yes, students? Right. So once again, why is water? I'll write the factors. Please watch the video which I have done. So first important thing, water dissolves ionic crystals because of larger dipole. That is one concept. So I'm again telling, I have done a video on dipole moment. Please watch that. Next, because of this large dipole, what is becoming high? High hydration energy. Correct? Yes. The next concept is, let us write that also, because of this larger dipole, high hydration energy. Hydration energy. Done. Now, next concept. It has high dielectric constant. High dielectric constant. So dielectric constant, how much is it? It is 78.5. At what temperature? At 25 degrees. At 78.5, 25. Because of this, as I told you, it reduces the attractive force between cations and anions in solutions. And once it reduces, it is easy, or it keeps the unlike charges there, and means this will make the unlike charges apart, and easily it starts dissolving in it. Correct? So for dissolving the suitable solvents for dissolving ionic compounds, first important thing, they should have high dipole, they should have high dielectric constant. So whenever somebody asks you how can you say it is soluble in that compound, means you have to say it has high dipoles as well as high dielectric constant. These two are the factors. Let's see conductance. So when I have to speak about conductance in ionic crystals, what are present? Positive cation and negative anion. And where are they present? They are present in fixed position. In the lattice, they will be present in fixed position, isn't it? And they are not mobile, they are fixed. So what will happen? Ionic solids do not conduct electricity in solid state. Yes. So first important thing, what should you remember? In ionic crystal, what is fixed? Ions are fixed. Right? So first important thing, ions are fixed. Right? Fixed. Means they are not mobile. Right. So when we have to see the conductance part, as I've told you, here in ionic crystal the ions are tightly fixed. But what happens, because of this fixed nature, whenever an ionic solid is there, you know, both the cations and anions are tightly fixed like this, isn't it? So when they're fixed, they do not conduct electricity, they're not free to move. But the same thing when you take the ionic molten or ionic solution, the ionic crystal in the solution part, you're taking salt and mixing up it in water. So what will happen, the distance between or the electrostatic force of attraction are broken and the ions start moving to the opposite charged electrodes, right? So then when the ions start moving, automatically the conductance of the means how much of a current it has to flow. So immediately the conductance increases. So remember, in ionic solids do not conduct electricity. In molten state, they're free to move and they conduct electricity. So remember, ionic solids, because they're tightly packed, no conductance. Molten state, there is conductance. Done, students? Yes. Now let me speak about the stereochemistry part of ionic compounds. Here, the constituent ions, means the ions of the ionic solid, what do they possess? They possess orderly arrangement, fixed arrangement, isn't it? And because of this fixed arrangement, what do they have? They have specific pattern. Means they are fixed cation, anion, cation, anion, anion, like that. They form a specific geometry. Correct? Yes. So these crystals always are, what do they have? They have plane faces like this. And these faces, where do they meet? They meet at fixed angles. One side, this one angle. Suppose if I take this crystal, all the cation ion, they have one plane faces and they have fixed angles. Correct? Even I told you, like the cleavage will be perfect like this. So for any particular substance, the angle between the corresponding pair of faces is always the same, isn't it? What did I say? Let me say. First thing, in an ionic solid, what do they have? They have orderly arrangement, fixed arrangement. First thing, correct? And because of this fixed arrangement, what do they have? They're going to possess definite geometry, fixed geometry. I have, yes, definite geometry. Done. And next thing, because of this definite geometry, what will have? What do they have? They have faces which always meets at fixed angles. These faces which faces which always meet at fixed angles. Correct? Done. Now, the angle between the corresponding pair of faces, the angle between the corresponding pair of faces, the other way, is always same. Angle between corresponding faces is always same, is always the same in all crystals. That's it, right? So this is how you have to study, students. These are the different factors which the ionic bond depends upon. So I have taken two different questions. I just took the factors, that is the melting point, boiling point. I took hardness, then I explained you brittleness, then I explained you cleavage concept, I explained you solubility concept, I explained you conductance concept. I also showed you what is the stereochemistry and how will the angles be, right, students? So hope the concept is clear. Today we have started with the combo classes. I have explained you what the two important things. That is the first question which I explained you is explain the factors that influence ionic bond. Next one, what describe the general characteristics of ionic bond. Thank you for watching. I'll meet you again. Please watch the video. I'm expecting your support, because if you don't watch it, it is meaningless for me to upload. So thank you so much for watching. I'll meet you again with the next concept of ionic bond. Stay tuned, stay happy.